welcome everyone. Hello, folks. So nice to be back for Data on Kubernetes Communities live stream number 119. Unbelievable amount of content, unbelievable amount of amazing content that we've been producing since we got started in July of 2020. And, starting things we got going last year, getting going this year as well. We got KubeCon coming up, folks. May 16th, there'll be the Data on Kubernetes Communities third co-located event in KubeCon. And really importantly, in order to make that successful, we need high quality talks, right? We're already getting some submissions. We've got some great content coming in, but we need more, right? The deadline is open. You got 2 more weeks, right, to get your talks in before the deadline expires on the CFP. All right, that's coming up pretty soon. So you want to get this stuff in there, all right? On March 16th, the CFP will be closed. So don't let that date creep up on you. If you've got questions about, what kind of stuff you need to get in there, we have very clear guidelines. I will happily leave this here in the YouTube chat so you can see them. We've got all this right here. All right. In terms of the stuff that we're looking for, so you know exactly what's being expected of you. And if you have any doubts, as always, you can contact us on Slack. That being said, our guest today is the CTO of a company called Data Center. And isn't that fitting for the Data on Kubernetes community? His name is Hakan. He's in Dusseldorf, Germany. Hakan, welcome to the Data on Kubernetes community. Can you just give us some fun facts about who you are before we get started?
Of course. Thank you, Bart, for the introduction. So fun facts about Hakan. Actually started out studying philosophy. That's always like in the technical community, like, okay, where does that come from?
Oh, no. You're in very good hands. I got my degree in religious studies. That's perfect. That's good.
So we're close connected there, Bart. And yeah, been here in the software industry for like 6 years, always in the data engineering realm. And huge fan of Liverpool FC, if that's interesting to someone.
That is interesting to me. And how did that fandom start? How did that happen?
Oh, that's kind of an interesting story. So in 2006, the World Cup was in Germany and there was a Spanish forward. He basically, Fernando Torres, he moved to Liverpool that year. And then I started following Liverpool basically since 2006 to 2007. And it stuck with me.
He's a great player.
Yeah.
And great blonde hair.
Yeah. I wish I had that hair.
Yeah, it's really cool hair. No, and yeah, very stylish player, very elegant player. That's cool. All right, so Liverpool, and then can you just really quickly, philosophy. How did that interest start, and then how did that shift later on to data?
So I would say it was kind of on, off, off, on, and off again. So basically, in high school, my interest in philosophy started. Before that, I actually wanted to develop games.
Okay.
And once I started philosophy as my major, I was kind of like, okay, will I earn money with this? And then switched my minor and my major.
Yes. And the answer was yes.
Yeah, I was not brave enough. Maybe. So I switched around with my majors and my minors. So basically majored in computer science later on, and kind of my interest in computers stuck with me professionally.
And here you are today. That's good. And that's interesting too, because a lot of times from talking to different folks, shout out to Rick Vasquez, one of our strong veteran community members. He got into, computer science originally because of playing Counter-Strike and just starting to tool around with different things there. And I think it can spark a sort of natural curiosity. So for anybody who's out there, who might be getting started on their Data on Kubernetes journey or whatever it happens to be, the technologies that we interact with, start thinking about them. And that's where I think maybe philosophy comes in. Question them, why does this happen this way? And what's the purpose of this? And why are these things coming together? There's much more than meets the eye. So, get under the surface. Anyway, tell us a little bit about Data Center, your job as CTO. What does this company do?
So DataCater, for that matter, what we
excuse me.
No worries.
Brilliant American pronunciation.
No, it's I think you see the end and the beginning of the word, and it's of course data center. So what we do is try to make streaming more approachable to a wider audience, and it's kind of, we saw a lack of tooling around data engineering and bringing kind of data analysts models or data scientist models into production. And that's how the idea around DataCater started. My co-founder and myself were working together at a bank where we across Europe saw these problems as internal consultants. I went on to go to AWS and later on joined this endeavor again. So it's basically trying to get ETL development into the modern times, I would say.
Okay. Helping ETL modernize. Wow, that sounds like there's like a European Commission grant for that of helping with
that would be great. That would be great.
European Commission, if you're out there listening, please give Hakan and DataCater a grant. All right. That being said, let's jump right into your presentation. I'm stoked for this. Remember, folks, get your questions in the YouTube chat. If you want to take the conversation further, of course you can do so in our Slack. But yeah, Hakan, if you want to start sharing your screen, all yours.
Perfect. Then I'll share. And thank you for the introduction again to everyone who's tuned in. Thank you for your time. Today, we want to talk about cloud native data pipelines. For that, I already introduced myself. We will take roughly 35 to 40 minutes. Without questions, let's see how long it takes with the questions. The first part will be about why do we need cloud native data pipelines and what we think cloud native data pipelines are. Then we'll do an excursion into Kafka and Kafka Connect, as they kind of are our backbone in terms of technologies we use. And the last third will be going down into the deep end with code snippets, what actually a data pipeline is in the ways we defined it before and how it looks like in code. So what we saw as data engineers is ETL needs evolving to the whole software industry kind of move from dev and ops to DevOps to GitOps to produce more stable software and deliver more frequently. And this iterative approach did not fully apply to the data development space, let's call it, or ETL space. So there's still some catching up to do. This catching up is also because of the legacy tooling that is not legacy, but because of the present tooling that's available, especially with Hadoop. And this leads to kind of a divergence between the runtimes from dev, test, and prod. So let's take Spark, for example. You start out developing your ETL processes on a local machine, but they will run in a cluster of up to 1,000 machines, maybe more, maybe less, depending on your needs. And often even like the test stage is significantly different than production. So your test run on different resources, which leads to the next point in that you have to kind of calculate what a worker can use to have proper scalability properties next to your business logic. So you're kind of mixing infrastructure and business logic partially. And the looking from a cloud native perspective or a Kubernetes perspective, there's a huge divergence between infrastructure description and the computations that you actually want to execute. So often you have distributions of Hadoop like Cloudera, or EMR or Google Cloud's MapReduce distribution or Hadoop distribution. And these are operated not often by the data people. So there's a huge divergence in culture and teams, but also in the tech and description. And we believe there are some cloud native principles that actually can help the ETL space. Namely 3 of them. Once I can separate and have a stateless data pipeline, I can auto-scale and horizontally scale without having my scalability properties and my business logic in the same place. What it also offers, as we have containers as the main runtime, we have image immutability, which is a great asset in terms of auditability, and every company wants to know which process transformed my data at which time and where did it land. And as you have immutable images, you can actually pinpoint what part, what code transformed your data. at what time, and this at what time you get from the Kubernetes logs, basically. And the third part is a declarative description. So you don't basically have operations team doing the description of the infrastructure and your team or the data team doing the data work and transformations and filters on the data, but rather you have it in the same place. And that's why we will also, or we are proposing that data pipelines should be able to be expressed in a YAML format. So on this journey, there are a couple of considerations we took to sometimes make our life easier to get the first steps done, but also where we think that these decisions enhance data quality, especially in data sinks. And we'll talk a bit more about what data sinks and sources are, how they work, in a couple of minutes. So we started out with streaming and event sourcing because this brings us continuity, predictable resource consumption, and we can more easily scale these pipelines as we can kind of externalize the state that we want to keep. And when we reduce the state in our pipeline, we of course need some system to keep this state and keep track of it. So we kind of went for the best in breed solution here with Apache Kafka and Kafka Connect to get data from various systems to Apache Kafka and get data from Apache Kafka to various data sinks.
Can I ask a very silly question here?
Of
Just
course.
Because we've, data streaming is a very interesting topic, and we've had a couple of other live streams where we've touched on this. In the decision-making process to go with Kafka, were there any other options on the table, such as Pulsar or something else, perhaps?
No, at that point, because the Kafka API kind of in this messaging realm became the default. And that's why we wanted to go with the default. So as we want to make streaming more accessible to a broader audience, we started with the de facto default as of the industry, and that's the Kafka API. And I'll also go a bit into that later on.
Good, no spoilers. Got it. Good question. Good, thank you. Good answer.
Thank you for the question.
No, just curious. Cool.
Yeah.
Good.
And when we kind of considered, okay, if we want to make this if we want our users to be able to declare a data pipeline, what can they declare? Should they declare the data state in its sink, or what can you actually put into this YAML format? And we came up with computations in a very broad sense, boiling down to filters and transformations. So first you filter and define which records should actually be transformed. And then you can also define the transformations. In a big picture, this kind of looks like this. So 3 different interfaces. Then you have something, a middle layer that we call a pipeline compiler. What we built actually at DataCater. And from that, you compile different pipelines and we run them on Kubernetes. Important, all of these 3 interfaces need to produce the same pipeline. So whether I configure UI with my computations and filters or in a YAML pipeline, what comes out needs to be functionally the same. Right now, our pipeline compiler allows no-code transformations that we predefined, and you can use them in the YAML, or you can kind of put in a Python script, small scripts to process the attribute. We'll inject the data sets there. And what a pipeline is in technical terms, it's basically, in our context, a Kafka Streams application, but we'll go into that and dig deeper later on. And to give a bit more of a practicality, what entails ETL or data pipelines in general is, so you have a business, you have a sales database, a product, and a customer database. What you want to do is you want to do analytics on it, so you can probably run better ad campaigns or monitor and forecast your revenue and whatnot. So what you would do is extract data, filter, transform it, join it if you want, and then push it here as example BigQuery, but often analytics databases or data warehouses like Redshift, Snowflake, Teradata, you name it. And this is kind of the major use case for ETL, that you have all the data in one space, especially now with the microservices all around enterprise systems, but also small startups. You have now a lot of different data sources across your company. So now let's start our excursion into Streamzy and Kafka. You see Streamzy for the first time. I'll go a bit in 2 slides. I'll go and explain why we use Streamzy to operate Kafka on Kubernetes. So what is Kafka? Kafka basically defined this messaging standard, and the API, and also the Kafka streaming API in Java was taken by other libraries and evolved, and it's kind of the default interface when you work with messaging right now in the industry. For example, Google pops up, and also Red Panda. I think the Red Panda folks also have spoken here at Data on Kubernetes.
Yes, they have. And shout out to Red Panda.
Nice, thank you. A later slide will also shout out to them again.
Oh, good. I'll be happy to hear that.
Yeah, shout out to Red Panda. So basically everyone adopts the Kafka API. It's kind of like S3, like you do a blob storage or object storage, you need to adopt the S3 API. And how Kafka works is Kafka brokers distribute messages to consumers. Of course, you can also produce into Kafka brokers, but why I mention the consumers here explicitly is consumers then need to acknowledge that they received a message. Messages are kind of grouped or stored together in topics. These are append-only logs, which are partitioned and then distributed across a given cluster for data retention. The acknowledgement part will be important later on. Just want to mention it here as a kind of, not spoiler, but outlook for the future. Kafka Connect then basically acts as a translation layer between Kafka and other data systems. And it's also a framework for creating messages from events or for events to external systems, because it can pull data from a data source, push it to Kafka, but it can also pull data from Kafka and push it to external data system. And Confluent has a lot of open source Connect implementations for various data sources, but also other companies and other people in the open source community are actually very active in this space. Let's go into Streamzy. So Streamzy, I think mostly backed by Red Hat, has the promise of making Kafka operations on Kubernetes easier, and it does a hell of a job there. So it's quite an amazing tool. Thank you for that, the open source community. And what basically you would do with Streamzy is, important note on this slide and future slides, everything that doesn't have a solid background does not run, or does not have to run in the Kubernetes cluster. Everything that has a solid background is running in our context in a Kubernetes cluster. So you have custom resource definitions defined by the Streamzy cluster operator. And with that, you can create a Kafka cluster and a Connect cluster, but also other Kafka ecosystem things like Mirror Maker to actually replicate another Kafka cluster to have like a hot setup, or just to back things up. And how we deploy our system is we had this Kafka Connect cluster where you register your connectors, give them a configuration so they know how to retrieve data and how to push data to external systems. Kafka Connect takes care of putting data into given topics that you configure it with and reading from it. The Kafka cluster right now needs Zookeeper for cluster coordination, which of course is a bit interesting in the context of Kubernetes, because often you don't install a new cluster on top of Kubernetes just to do cluster coordination. But with 3.0 and the upcoming versions, they say their internal system craft will be able to handle this, and we can get rid of Zookeeper soon, hopefully. And our pipelines actually only interact with the Kafka cluster. They are aware of the connectors, but they mostly interact with the Kafka cluster to read from topics and write to them. To kind of zoom in into a pipeline, this is the flow of data that we utilize. So getting data from a data source via connect, this goes into an in topic. We apply filters and transformations. We push it out. Then another sync connector gets from this topic, reads from this topic, and pushes out to a given data sync. There is a problem with this in how Kafka Connect is set up. So at least for us, we run hundreds of connectors on a given cluster, and we do not have control over whether they share a given pod or not. And Kafka Connect does not allow you to give resource descriptors to a specific connector. So what can happen is you have multiple connectors, multiple processes running on the same pod, and then one of them, for example, goes rogue. The whole pod will crash. If you had 10 connectors running there, they all crash together. And coming up is not so easy, because during that crash, it might have forgotten to acknowledge or not be able to acknowledge the last message. So it might crash always. Another problem is, I roughly spoke about auditability. It's hard to monitor connectors in the setup because you don't have separation of concerns per pod and have multiple connectors running in the same pod. And with all these things, what we concluded is, okay, we'll not run a Kafka Connect cluster. What we will do is we will deploy our own connector per pipeline, and we will have one source and one sync connector per pipeline. This gives us new capabilities, mainly being now able to also auto-scale the connectors with more control via the Kubernetes API. So if our deployment of a source connector or a sync connector needs more throughput, we can basically say, hey, please scale this to X nodes or X pods, X replicas, and we can now have 3 components scaled independently, so we can actually fine granularly say, hey, okay, the sync connector is our bottleneck. Let's remove that by scaling the sync connectors. One note here, the source and sync connectors, of course, still go to the Kafka cluster, but the diagram looked a bit ugly with that, with those errors, so I left them out of here. And we still utilize Streamz to deploy Kafka and Zookeeper and operate this. Now, we'll go down the deep end and we'll go through the whole process of actually building a pipeline and what it entails and how it looks very practically. So what we want to do is we want to take a YAML description of a pipeline, apply this, because apply is, I think, everyone's favorite word in the Kubernetes community. Then the pipeline compiler takes this declaration, compiles it to a Java Quarkus app. This app then gets built into and baked into a DoK, a container image, and we push this out to a registry. I'll not show code for the deployment because I think everyone in the Kubernetes community is aware of how to create a deployment on Kubernetes. With that being said, let's dive into it. So a very simplistic pipeline for us, a declaration of it on the left-hand side, looks like this. The spec has three major fields. That is a source schema, filters, and transformation steps. The source schema is basically a list which maps a given attribute name to a data type. Apologies for the noises if you heard some. And the filters basically define, here it would be, hey, please only process the records that are in between 0 and 100. So, or between 1 and 99 to be specific. And the transformation steps actually apply functionality or transform the data. Here, what it would do is it would add 100 and then transform it to a string. Yeah, very simple. So in the picture we saw before, what we will now build is, or what we will now push out is the red part and how we connect it to topics in and topic out. This is the most simple version of a pipe. And this is what we kind of, let's say, compile from a given declaration. So we first have a by predicate in Java terms. It takes a value and a predicate that it tests against. We just saw the definition of the two predicates, which are our filters. It's less 100 or greater 0. One note on this is a very specific example. In our generic example, it's really a lot of generics flying around, and I wanted to keep it simple and digestible. So now we have defined our predicates and filters. We will now define the two transformations. So we have a function which takes double, returns a double. In Java, this is an unary operator. And the toString function here explicitly would return mathematical notation. And this is just to also have a, let's say, type conversion in it. And what we do then is basically we generate a list of these predicates, apply them to a given value. We always, if you would think in tabular data, we work column-wise. And we kind of take then each record per column and apply the list of filters. If these predicates fail, then we do not process. So if these predicates fail, we do not process them, as you can see here. And the line multi.create from, where you see a comment at the end, .empty, we'll talk about that on the next slide. And in the else statement, what we do is basically now from all the functions that you want to get applied to a certain element, we compose them together and then apply them to your data so that we can return this result. And as you can see from the signature, a number goes in and a string goes out. Perfect. Now a bit more explanation on the signature of our pipelines. So in messaging and streaming, what we often need to do if we consume something is acknowledge that we received a message. And in Quarkus, they use smallRye as, or the smallRye library is packed within it. And the multi-class actually automatically handles this acknowledgement for you, and you can define multiple strategies. We use throttled, which I think is also the default strategy, but it's important for us to use this strategy as we only want to deliver a message once, and the throttle strategy actually allows to do that, because what we want to avoid is having a duplicate in our data sync. With this acknowledgement mechanism, what we also need to do, of course, is when we do not write anything to the topic out, we want to still send the acknowledgement that we have received the message, because we don't want to process it at a later point in time. And this is what multi.create from .empty does for us if we return that. So there goes an acknowledgement back out to Kafka saying, hey, I received this. And this what Kafka then does is it increases the offset for this given topic and consumer. Why I would encourage everyone to use Quarkus in this context is basically this slide. So it's an easy way to get, first of all, libraries working together, and especially in reactive messaging, they pack, I would say, the best of breed libraries. And it comes, for example, with high observability features baked in. So every channel that you use and every message, you saw the annotations 2 slides before, incoming and outgoing. These are the channels. You get the metrics and performance criteria or features like the P25, P99 of delivery time, etc. And this comes out of the box, which is great. One thing that's not on the slide, it's actually quite hard to compile native binaries from Java's Kafka Streams libraries via GraalVM, and Quarkus handles this for you as well. So you get better startup time of your containers, and their size reduce immensely. So instead of packing a JVM, you actually only pack a given binary, which is great. Then in dev mode, I think this is where Quarkus also shines. Instead of having to have a Kafka cluster running, they actually install the container vectorized /redpanda. Now, shout out to Redpanda. Thank you for this amazing piece of engineering that you can easily run a single node Kafka cluster or Kafka-like messaging system. And the dev tools are impeccable. So you get basically method profiling, test coverage, and also you can see the messages that you send into your channels across and their performance characteristics within one interface. It spins it up on if you hit play in your IDE or via your terminal. And it's just a pleasant experience to work with and quickly get up and running with messaging, but also optimizes then, of course, for Kubernetes. Now we know what a pipeline is. The last step, or one of the most important steps to actually make it run on Kubernetes, is to build a container. And here, just a comment: all the static fields and assignments that you see in terms of int and string, these are usually configured via the YAML. Just want to keep it simple here. So what we do is basically, we first of all pull a base image that we have for our pipelines. We are not building a base image within the process. And then we'll talk about points 1 and 2 later on. We also define and log into our target image registry and have a reference to that. what you also can quite easily do with Jib container builder is you kind of define a consumer, a Java consumer with a lock event. The only caveat is here, this lock event is part of the Jib library, so you kind of need to convert it to Java native logging again. But apart from that, you can have as many logging consumers as you want and have them for different levels or also different steps of the containerization process. And we'll go into that somewhere at the last line. So what you then do is basically you give Jib your base image, you add a layer that's your context and where this should be copied into the container. You set a working directory, and for us, we have a small script that's in there as well. You press start, or you tell the container the set program arguments kind of correlates with the CMD argument in Docker files, and this is basically a very simple Docker file from jib.from until the last line. And the .containerize usually would not give you any SCD output or any log events. So what you need to give it is, hey, I want it to be containerized in this way, and please add event handlers. And on any events in the lifecycle, you can define a log handler for that, which is great for observability. And in our use case, actually quite important that it was successful and we can deploy the image. Now, what you should consider when using Jib and might be important for you, depending on if you how your registry setup is. So the first thing is, what we do is we actually always on startup of the application build an example image just to have the base image cached on the local node. Apologies. So that once our users create a deployment, we call it deployment, but they actually create this image, it just goes faster. And then you can also start caching more layers. And each new build just then adds a layer and does not have to pull any image from somewhere else. The Jib container build kind of brings all the default Docker credentials and has retrievers for them. But within Kubernetes, if you have, for example, key rotation set up, there is one problem because it uses secret mounts to kind of read the auth mechanism from your home directory, which perfectly works with Kubernetes. But if there's key rotation in place for these registries, you kind of need to pull them all the time, as this would mean you have to restart your pod to get the new credentials every time you want to build something. And that's, of course, not a pleasant experience.
Real quick question from Ravi Singh. Thank you, Ravi, for the question. Are the pipelines using schema registry to define in and out data?
We don't utilize a schema registry right now. This is actually up for debate internally, because what happens if you apply filters and transformations is, of course, the schema evolves during that time. And sometimes we actually have evolving data sinks. So what we're still in debate if we would use, for example, Avro schema registry or something like that, or a Hive metadata store. This would mean we have to have multiple places where we adjust a new schema. So no, not at this point, to be simple. I hope that answers the question, Ravi.
I do as well, but if it doesn't, Ravi will let us know and we can continue the conversation. Good.
Perfect. And with Jib, what is amazing for us is it yeah, the log messages and the granular detail you can get from there, it just helps us being very, very detailed about what is happening and pushing this forward to our customers. Now, this was the whole process. We pushed our pipeline to an image registry. In our context, the last thing we do is actually on the press of a button or on an API call, what we do is we run a deployment with a newly created image. I spared you of that detail because that's basically using the Kubernetes API in Java, and it just doesn't look very pleasant. So what we have now talked about and what we are trying to achieve at DataCater is kind of summarized in this slide. So we want to make ETL more cloud native, and there are still some open issues around this. So as we saw with Kafka Connect, not all the tools are self-contained or get like this self-containment principle that you can that you want to have within cloud native applications. It's still an evolving space. Like if you look at Streamsy, if you look at also Red Panda, a lot of the tools that we utilize right now are before version 1.0. We encounter some rough edges, but I also have to admit the community is great. So everyone is approachable. If you want to talk to the people or chat with the people from who are developing Streamsy, they actually reply quite fast. So I think it's a good place, but it's still, there's room to grow. And what we think would greatly or should benefit the industry is there is no specification of what should be in a declarative data pipeline. So let's say with the Kafka API, you kind of have a consensus around, okay, for messaging, Kafka API sets a standard. It's not a written RFC, but still, you know, it's a good way, a good guideline on how to implement and how to create your interface if you build a message broker. And we at DataCater here kind of try to give back to the community our opinions about it. And we are making first steps and trying to engage with the community on how to actually define this. So any feedback is welcome here, really. But with that being said, there's some benefits that are already out there, and we have the pleasure to use. So with Apache Kafka, you have strong messaging technology that's kind of deployed everywhere and anywhere in the world. Confluent is doing an amazing job there. And, you know, it's evolving. You have other messaging technologies such as Google PubSub or Red Panda, which are adopted more and more. And it's just already quite mature technology. Ecosystem in terms of dev with Java Quarkus quite pleasant. And of course, in the Kubernetes community, a lot of the people are not Java people, but a lot of data technology actually is developed in Java. So having Java Quarkus as a cloud native way to do Java is really helpful. And last but not least, the folks at Streamsy do a great job at easing the burden of operating Apache Kafka and Co easily. So I think without these folks, having Kafka as Zookeeper and Kafka Connect run on Kubernetes would be 100 times more painful. With that being said, I would shout out and say big thanks to all of you who tuned in, and especially thank the folks and teams behind Streamsy, Kafka, Quarkus, and majorly Bart and your team at the Data on Kubernetes community.
Much appreciated. I would also like to add there too, I think it's a really good point that you're making. And as usual, we're like blending, you know, the human and technical sides of this stuff. because in this case of Strimzy, I can speak to personally about the fact that we had one of the maintainers,
Jakob Schultz.
Yeah, one of the nicest people on this planet. I hope he clones himself and sends a replica to every single country in the world. He's amazing. We need more people like him, particularly in times like right now.
Yeah.
And so that's the thing, is that if you have questions about that, if you're struggling, reach out to him or anybody else who's on the team, and they will patiently guide you through whatever problems you're dealing with. Just remember that, basically a lot of this just comes down to reaching out and asking people, getting informed, and don't be overwhelmed. And like you said, don't make data on Kubernetes 100 times more painful than it needs to be.
Yeah.
I think that's a really good point.
Also, as a last point, like whenever you have questions around our implementation and what we think about data pipelines, please reach out to me. You can find me on Twitter under @HKNLOF or via email hakan@datacater.io, which I think is simpler to remember.
Yeah, either way. No, but I'll drop your Twitter. You're packed. You're loaded up on Twitter. We got a couple of questions though. First question from Lars. So what do you think about KSQL as a declarative data pipeline?
Interesting approach. Mismatch with the data processing community, let's say. So a lot of data scientists, data analysts, and data engineers work majorly in Python. So it is an important approach, I think, KSQL, but it lacks some of the flexibility that especially the data consumers want to see, and that flexibility right now is utilized within Python.
Hey, good. Let's Yeah. Well, he's got time. Don't worry. And then another question from Ravi once again. How and what are you doing to test the pipelines?
Yeah, that's quite great that you asked. So what we are working on is, as I mentioned before, in these classical ETL toolings, you have a divergence of environments. And in our approach, what you can actually do is, if you have a declarative description, you can actually execute everything and run a sample data set through it. So what we want to provide and what we are working on is like a CLI where you can say, test my pipeline. And then on a sample data set, it will take your declarative description, build the image that would run on Kubernetes, and run through all your sample data set, and you can put that in a CI process.
All right, sounds good. Now, can I get you to stop sharing your screen actually really quickly?
Yeah, of course.
No, but before we wrap up, and also since we started out talking about philosophy, as you are a philosopher, whether you like it or not, doesn't matter if you have the degree. One of the things that we talk a lot about is a recurring question, is the very nature of this community. So one thing is, what is data on Kubernetes when we're talking about that? And it's nice to have a talk today about data pipelines and bringing in topics that are pretty strong in the data engineering world, as opposed to we want to say DBRE or SRE or more the DBA side of things. But apart from that, in terms of what data on Kubernetes is, the ecosystem, we see different use cases, how it's being done in terms of these technologies, getting to the more philosophical question about why, right? It doesn't have to be philosophical. We can look at this in different ways.
Yeah.
But in your opinion, if you're dealing with a customer and you say, hey, we're going to do this, and they ask you why, how do you respond to that? We've heard different responses from different people, but I want to know your response, Hakan.
Okay, let's start with the operations side of it. With Kubernetes, let's say you install it on any given distribution, and you immediately have a tool that's hooked up into your monitoring system. That's the first bit. The second bit is what I described before, as in Kubernetes. When I think of it as an operating system to run containers, so basically and managing the resources around it. Having a container which describes your data pipeline is a huge advantage, because now you can say this exact revision with this hash that was the thing that transformed my data into that. So you are fully auditable. And the last bit is being the ability to declare what you want, and Kubernetes giving its best to get to that state. So these three things really make it up for me, and why you definitely, I would say, if you asked me 3 years ago why data on Kubernetes, I would have said probably you will have a rough time. It has gotten better, but I think these are the three major things that I see why you should do data on Kubernetes.
And what would you say the difference between 3 years ago and now? Just some of the key points.
Stability of the ecosystem, things like different storage providers that, different storage providers, and the stability of them is basically major improvement.
Like you said, we find ourselves in a situation now where there are more resources, where there's more know-how. And that's the very nature of this community, is getting those folks together to share those ideas. It was really nice to see as well that getting shout outs to the Strimsy folks. Like I said, massive shout out to Jakob Schultz. And then also as well too with Red Panda, we had a really good live stream with Red Panda. So seeing those, come together here with DataCater, I think is very exciting.
Yeah, thanks to you
and your team. No, but it's cool because sometimes it seems like you're just going down a direction, then and then 6 months later, like, oh, these things are not coming together. So that's really positive to see too. That being said, we are getting towards the end, and we have a bit of a tradition in our community. So while we've been talking, we have an amazing person who's not a philosopher, but also well, he is actually kind of is, and hopefully you'll get to meet him someday. So while we were talking, our amazing artist Angel is in the background, created a depiction of all the different things that we're talking about, and you touched on quite a few different topics, right? So we get a nice artistic sort of summary of the things that are being mentioned here, and I think as usual he did a pretty good job. You mentioned some things about following up, right? So I've got your Twitter, and I'm gonna put your Twitter link in here. So if folks want to reach out to you, but as you said, I mean, you're also in our Slack, so that's a pretty easy way to do it too. And I will also put the link to DataCater, so you can see the stuff that's going on there. I said this before we got started, but I think several of the things that were touched on in your talk today could very much work for our co-located event in KubeCon. As this was very vendor neutral, you're not pushing, a pitch or anything like that. It's nice open source technology. And like I said, the convergence of these things that we've had on previous live streams. So definitely do that. And to the folks in the audience as well, do the same. Please follow DataCater. Please follow Hakan. I'm going to be following you, whether you like it or not. And I hope that we get to see each other, whether it's in Spain, whether it's in Germany, whether it's in Turkey, I don't care. But I hope that by the end of this year, and certainly next year, that we'll be able to hang out. It was very nice having you today with us. Folks, as usual, if you want to continue the conversation, get in Slack. We'd love to hear from you. Hakan, have a wonderful day.
You too. Thank you for doing all this for the community.
Totally worth it. People like you make it all worth it. So good day.